Welcome back. That is a unusual break by the Zoom because after 40 minutes you have to reconnect. So we started to study the Gauss-Markov theorem, which is also known as the blue property of the OLS estimators. An estimator, say the OLS estimator beta 2 hat, is said to be a best linear unbiased estimator blue of beta 2 if the following hold. First one, it is linear, that is, it will be linearly associated with the dependent variable y, which means that beta 2 hat will be a linear function of the yi. In the second one, it will be unbiased. That is, expected yield of beta 2 hat will be equal to beta 2. This is known as unbiased property. That is unbiasedness, which means that expected yield of a parameter, I am writing it in general form of a, say, a statistic, which is equal to its corresponding parameter, then the statistic is said to be unbiased. In regression case, if expected value of the beta 2 hat equal to beta 2, then we can say that beta 2 hat is unbiased for the beta 2. And the third property, that is the minimum variance criteria, here it is that if it has minimum variance in the class of all such linear unbiased estimators, an unbiased estimator with least variance is known as the efficient estimator. As I told you, that suppose that we have the two estimators, say B2 hat and B3 hat. So which one will be the efficient? The one having the minimum variance. I will provide you the complete proof of this segment. That is the blue property of the OLS estimator, a mathematical proof, and it is also important for your midterm and for the final term exam. This is a comprehensive proof where it has been shown that the OLS estimators are linear, unbiased, and they are having the minimum variance. So here it is. The sampling distribution of beta 2, the sampling distribution of beta 2 steric, and the sampling distribution of beta 2 and beta 2 steric. So we shown that the variance of beta 2 is minimum than that of the beta 2 steric, and the one having the minimum variance will be preferred. So they shown in the first one that here it is that beta 2 hat is also unbiased for beta 2 and beta 2 steric is unbiased for the B2, and these are their corresponding distributions. And in the C graph they shown the both distributions in one graph. So the one will be preferred that having the minimum variation. So it is clear that, or you can read it in the book, the details will be available there, that whose variance is minimum. So this is your homework. You have to tell me by tomorrow that which variable, show me or tell me that whose variance is minimum. beta 2 hat or beta 2 star. Look at these two graphs and then decide that किस वेरिएबल किसका बीटा 2 हैट का वेरिएंस मिनिमम है कि नहीं बीटा 2 स्टार का. The next topic is that of the coefficient of determination. By coefficient of determination, we mean that how much variation will be explained in the dependent variable by its linear relationship with the independent variable. The result of the coefficient of determination will be usually expressed in percentage, and the value will always be between 0 and 1. If the values of r square equal to 0, which means that there is no relationship, or the independent variable failed to explain any variation in the dependent variable. Similarly, if r square equals to 1, which means that 100% variation in y is because of its linear relationship with the x, and the value of r square always lies between 0 and 1, and its formula is written over here. So to find out the coefficient of determination r square, you have to find out the total sum of square, explained sum of square, and residual sum of square. Total sum of square equal to explained sum of square and residual sum of square. Now, formula for the total sum of square is this one. This is the total sum of square, summation by I square, and at the end you will get this one. So here it is a graph. We already studied this one in the previous segment. Say this is some values of xi, this is the mean, this is the sample regression function. Now the difference between the yi minus y bar, this is the total variation, this one, because this is yi, this is y bar, so yi minus y bar, this is the total. This is our fitted regression line. So the difference between yi minus y hat, this is ui hat, and yi hat, this is yi hat, this one, the estimated value. This value over here is y bar. So yi hat minus y bar, so this is due to regression. So the total variation, that is yi minus y bar, this is total variation, that is split in two forms. One is due to residuals and the other is due to regression. So this is the total variation. Here it is, this one, that is yi minus y bar, yi minus y bar, this is the total. Similarly, this point, or say this line, this is the estimated regression line. When you find out the values of beta 1 hat, beta 2 hat, then fit the values of xi, so you will get this line. On this line, we consider a value which is yi hat. This is yi. Now if we subtract this actual value from this estimated one, so you will get the error ui hat. In the second case, again, this is yi hat. This is our mean y bar having some value. This value will be equal throughout. Say we have a y bar value, and we just draw a straight line over here for each value of xi. For the given value of xi, we have a mean value. So this is the conditional mean. Actually, we discussed it earlier lecture. So yi hat and minus ui. What is this? This is the variation due to the regression. So the total variation is split into two forms. One is due to residuals, and the other is due to the regression. So if you look at the previous slide, this one, the total variation is split into two forms. That is explained sum of square and residual sum of square. Explained sum of square is also named the regression sum of square, because it has been explained, those variation which has been explained by the independent variable in relation with the dependent variable. This is known as the explained sum of square. Now again, coefficient of determination. Now we will derive its formula, that how it can be calculated. As we know that in the previous slide we discussed that the total sum of square is divided into explained sum of square or regression sum of square and the residual sum of square. Remember that RSS is not for the regression sum of square, but this is actually for the residual sum of square. And E is not for the error sum of square, but this is for the explained sum of square. So E for explained and R for the residual. Divide it both sides with the total sum of square. So ESS divided by total sum of square and RSS divided by total sum of square. How can we calculate it? Explained sum of square. So explained sum of square is actually yi hat minus y bar by, this is the sum of square, so this is the sum and this is the square. In the denominator we have the total sum of square, which is summation by I minus y bar square. This is the residual sum of square, summation ui hat square, and divided with the summation by I minus y bar square. Now r square equal to ESS divided by total sum of square. This is the ESS formula written over here. This is the total sum of square written over here. So we have to put r square for the value of this one. This is nothing. This term is actually the r square, which is written over here. Sorry. Yeah. So we will fit r square for, we will fit r square for this term. This is r square, where we put r square and we'll bring this one, we'll shift this one to the left side. So it will be 1 minus this one, 1 minus this one, and this is r square. So 1 minus, what is this? What is this? This is RSS, which means this is the residual sum of square. What is this? This is the total sum of square, this one. This is the total sum of square. So finally, we have the formula for the R square, which is known as the coefficient of determination. And it is R square equal to 1 minus RSS divided by TSS. The formula for the RSS is given, as well as the formula for the TSS is also given. The formula for the RSS is this one, and so on. The quantity R square, thus defined, is known as the sample coefficient of determination and is the most commonly used measure of the goodness of fit of a regression line. Verbally, R square measures the proportion or percentage of the total variation in Y explained by the regression model. For example, if R square equal to say 0.4, how to interpret this? This means that 40% of the variation 40% of the average variation is Y explained by its relationship with X. So interpretation of the R square will always be in the percentage. Value of R square will always be between 0 and 1. It may be 0, it can be 0, and it can also be 1. If there is no relationship between X and Y, then R square will be 0, or maybe approximately 0. Similarly, if R square equal to 1, then there will be a perfect relationship between X and Y. For example, if you want to find out the relationship between your shoe size and your CGPA. So theoretically, as it is clear that there is no relationship between the student's shoe size and his score in statistics, his score in mathematics, or his CGPA. So if we run this regression and find out the R square value, so it will be equal to 0, and so on. So in this case, the R square will be 0 or approximately equal to 0. So this is the final result we have, the value of R square. Now, again, we need to set the mathematical formulas for the ESS and TSS. So ESS, this is summation yi hat square, and TSS, this is summation yi square. So again, summation yi hat square, this is equals to beta 2 hat summation xi square divided by summation yi square, and beta 2 hat square summation xi square divided by summation yi square. R square equal to beta 2 hat. What is summation xi square? This is actually variance of x. What is summation y square? This is actually variance of y. So we will fit s square x and s square y. So R square equal to summation xi by I whole square and divided by summation xi square and summation yi square. So this is how we get the last one. We just feed the value of beta 2 hat, and after fitting the value of beta 2 hat, we get this result. So the formula for the R square can be, you can use this one. आप लोग ये फार्मूला भी यूज़ कर सकते हैं, ये वाला आप ये भी यूज़ कर सकते हैं, आप ये भी यूज़ कर सकते हैं, आप ये भी यूज़ कर सकते हैं, जो आपको कन्वीनियंट हो। और डिपेंड भी करता है डेटा के नेचर पे। सम टाइम डेटा ऐसा गिवन होता है कि उसके लिए जो फॉर्म रिक्वायर्ड होगा तो वो फॉर्म फिर आप जो है वो लगा सकते हैं। सो दिस इज ऑल अबाउट द कोएफिशिएंट ऑफ डिटर्मिनेशन। अगेन some further formulas are given. That is ESS equal to, let me explain this a little bit, as R square equal to ESS divided by TSS. Now multiply both sides with TSS, that is TSS multiplied with R square, which will be equal to ESS. So if we look at this one, ESS is equal to R square into TSS. And what is TSS? Total sum of square, which is equal to summation yi square. Again, note that yi square is in deviation form, so that is capital yi minus mean of capital yi, and that is square. Remember that when we have small yi and small xi, that will be always considered in the deviation form. Again, total sum of square, as we point out in the figure in the previous slide, this total sum of square is equal to explained sum of square and plus residual sum of square. ESS is for the explained sum of square and RSS is for the residual sum of square. So RSS equal to TSS minus ESS. Now taking common TSS, so you will get 1 minus ESS divided by TSS. So what is TSS? Total sum of square. This is summation yi square. 1 minus what is ESS divided by TSS? This is actually R square written over here. So TSS actually ESS plus RSS. What is TSS? Summation y square. What is ESS? This is R square summation yi square. Here it is written ESS R square summation yi square plus RSS. What is RSS? This is 1 minus R square summation yi square. So from here you can find out R square equal to summation yi square. Just explain. This is in deviation form, so we can write summation yi square. This is in deviation form, so you can write it capital Y minus mean of Y and again y minus mean of y, because this is square, because this is sum is for the sigma, as we haven't any symbols. Y is a small deviation form, So sum of y squared equal to y minus mean of y, and here it is. First we have to divide this by 1. That is to obtain, we need some mathematical calculations over here, because we have to get the value of r square. This one r square is related with the summation y square. Similarly, again this is related with the summation yi square. So you will get at the end. Just do it by yourself. That how we can get the final formula for the r square, which is summation yi minus y bar, summation yi minus y bar, and yi hat minus y bar square divided by summation yi minus y bar square and summation yi hat and minus y bar square. We can also write down that r square equal to summation y hat. This is again in deviation form, because yi minus y bar in deviation form, that is written in small yi hat minus y bar, this is written in the small yi hat. Similarly, this is small yi and this is small yi hat. So this is the final result, and the coefficient of determination having the different forms. You can use which one is convenient to you, you can use that one. Okay, so let's move. You can also read it in the book. Now, what is coefficient of correlation? Coefficient of correlation is actually the square root of the coefficient of determination. When you put square root on the coefficient of determination, you will get the coefficient of correlation. Here its formula, where r is the sample coefficient correlation. You are all requested to please read down this topic in the book. Coefficient of determination, all these formulas, their bases, their derivation will be given in the book. So here's a figure. You can see in the first case, in the first figure, that here r equal to +1, because there is a perfect correlation, perfect relationship between x and y, and all the observed points are on this one. The line is fitted 100% accurately. X, all variation in y is explained by the linear relationship with x. In the second case, this is the coefficient of correlation, not the coefficient of determination. There is a positive correlation between x and y. In the second one, there is a negative correlation between x and y. In this case, r close to +1. In this case, r close to -1. Here, r positive that close to 0. R negative that's close to 0. R 0, no correlation. And r is again 0. There is no correlation between the two variables. So these are different figures showing that the correlation between X and Y. Now, here are some properties of R. And inshallah, we will study this topic in tomorrow's session. Some of the properties of R. Now I'm unmuting all of you. If you have any question, you may ask, or you can write it in the chat box. If anyone have any question in their mind regarding the lecture today, you can ask it by unmuting yourself. I give you the option. I'm waiting. If anyone have any question, so kindly ask it, or if you don't need to speak, then you can write it in the chat box. And Zishan will be responsible for attendance as in the college. So he will check that who's absent and who's present. Gee, any question? If you have any question regarding today's lecture, you can ask. ओके अगर क्वेश्चन नहीं है तो होपफुली आपको समझ आ गया होगा, इसलिए आप क्वेश्चन नहीं कर रहे. Anyhow, so this is all about today lecture, and inshallah we will meet tomorrow at the same time, and our tomorrow topic will be some of the properties of R. Until now, Allah Hafiz, take care of yourself and your families in the current situation of pandemic of the COVID-19. Allah Hafiz, take care, goodbye.